One of the systems we're trying to study is basically a giant colloidal molecules. We try to use colloidal particle to make structures that showing chirality. You know that chiral molecules is of great interest, and one of the reasons related to the origin of life. Most of the biological molecules in our body or in the living system, actually, they're not just a mixture of left-handed and right-handed. Some molecules are purely just left-handed, some molecules are purely just right-handed. How could this happen at the beginning or at the origin of life? That is an outstanding question. Nobody knows yet. But people believe that selective chirality at the beginning of the life plays a significant role in terms of the evolution of living species. Technologically speaking, materials showing chirality is also going to be quite important because the interaction with light. And you know that the polarizability of the light is important, and that would show different properties when you have left-handed structure versus right-handed structure. But thermodynamics speaking, left-handed structure and right-handed structure, they have same thermodynamic energy. So in that sense, if you just rely on classical thermodynamics, you're not going to make a structure that is just purely left-handed or purely right-handed. But one way to break this symmetry is to use external fields and to utilize the active motion of that structures. And in fact, by doing that, we can break the symmetry and we can make structures that only have one chirality in that. So this is example that you can, if you move the system from passive to active, you open a new world that you can utilize those motion, dynamic motion, active motion of those building blocks to create materials that you won't be able to make previously. We are always imagining that using those colloids as small Lego pieces and to make functional structures, let them assemble and make functional structures, right? Previously, we rely on the interaction or equilibrium interaction between particles to do that job. Now, why not envision that we can let each of these Lego pieces become a small micro robot? Each of them moves, and in that sense, maybe they will assemble into structures much more efficiently compared with the passive types of Lego pieces. So that's why I think active matter is going to be a very important subject in the soft matter physics community to study, and having the capability to use external fields to drive those building blocks and at microgravity environment is going to be very important to the scientific community. We feel very fortunate to work with great teams at Glenn Research Center who helped us to test our samples and devices and make sure everything is good before sending to the space station, so we minimize the risks at space station. They are extremely helpful and they are very dedicated.